Hi, welcome to this lesson on calculus, the factor and remainder theorems. Let's have a look at using the factor theorem question 3. So we're going to factorize the cubic expression x cubed plus 3x squared minus 24x plus 28. So firstly, all the factors of 28. So that's plus or minus 1, plus or minus 2, 3, no, plus or minus 4, 5, 6, no, 7, yes, plus or minus 7, 9, no, 10, no, 11, no, 12, no, 13, 14, so plus or minus 14, and then plus or minus 28. So there are 1, 2, 3, 4, 5, 6, 12 factors in total to check. So hopefully we can pick one. I usually always start with the smaller factors first, so when I put it into the polynomial, I don't have to do such large calculations. So if I do p of 1 first, so it's 1 cubed plus 3 times 1 squared minus 24 times 1 plus 28. So that's 1 plus 3 minus 24 plus 28. Well, negative 24 plus 28, that's positive 4. So I'm left with 8 here, which is not 0. So x minus 1, that's not a factor. What about negative 1? So I have negative 1 cubed plus 3 times negative 1 squared minus 24 times negative 1 plus 28. So negative 1 cubed is negative 1. Negative 1 squared is positive 1 times 3. Negative 24 times negative 1 is positive 24, and then plus 28. So again, this is going to be a much bigger number. Negative 1 plus 3 is positive 2. That's already 30, that's 54. Again, that's not 0. So x plus 1, that's not a factor either. Okay, we move on to the next one. So let's try 2. So at 2 cubed is 8. 2 squared is 4. 4 times 3 is 12. Negative 24 times 2, that's negative 48. And then plus 28. This looks promising. 12 and 28, that's 40. Plus this 8, that's 48. Minus 48, so that's 0. So therefore, x minus 2, that's a factor. Okay, so first let's go through logical inspection. So with logical inspection, we have that x cubed plus 3x squared minus 24x plus 28. This must factor into x minus 2 times some quadratic expression. Okay, so what's that quadratic expression? Well, in order to get the x cubed, I need an x squared term. In order to get that positive 28, I need negative 2 times negative 14. So I just need this bx term in the middle. So again, I can do comparisons. I'll look at the squared terms on both sides. So I'll say 3x squared on the left must be equivalent to the x times bx, which is bx squared, times the negative 2 times x squared, that's negative 2x squared. So if I add 2x squared to both sides, I get 5x squared on the left becomes bx squared on the right. And then dividing both sides by x squared, I get b equals 5. So therefore, the factorization of this should be x minus 2 times x squared plus 5x minus 14. But this quadratic expression can be factorized further, right? So it can be as x minus 2. So the factors of 14, I can use 7 and 2 here to get a difference of 5. So I'll use x plus 7 because I want a positive 5x and an x minus 2. Okay, so you can see x minus 2 is a repeated factor. So we can write it as x minus 2 all squared because you're multiplying it by itself times x plus 7. So this is the full algebraic factorization of the original cubic expression. All right, let's do polynomial long division to double check. So polynomial long division, the factor was x minus 2 into x cubed plus 3x squared minus 24x plus 28. Okay, so if I multiply x squared by this linear term, so I'm subtracting what? X cubed minus 2x squared. So that gives me 0x cubed, and then 3x squared minus 2x squared, that's positive 5x squared. And then bring down your other terms, so negative 24x plus 28. So how do I get rid of that 5x squared? Well, if I multiply by 5x here, so it's subtracting, 5x times x is 5x squared, and 5x times negative 2 is negative 10x. So again, 5x squared minus 5x squared, that's 0x squared. Negative 24x minus 10x. So that's negative 24x plus 10x. So that's negative 14x. And then 28 minus 0 is just 28. Because we're bringing it down. All right. And then lastly, to get rid of that negative 14x, right? So if I do negative 14 here, and I multiply it into that linear term, I get negative 14x plus 28. Okay, then that'll give me 0x plus 0 when I do the subtraction. Therefore, we have a remainder of 0. So again, that's exactly the quadratic expression we derived using logical inspection. We found that we have that same quadratic expression when we do polynomial long division as well. All right, so it's always great when we see the different areas of mathematics agreeing with each other. Although the concepts might look a little different from time to time, they are both saying the same thing. All right, so that's how we would do this type of question. I'll see you in the next one.